Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. This is more nonsense, usual calculus nonsense. This is partial fraction decomposition. You're actually finding the integrals of functions using this method. Keep in mind that the denominator has to be able to be factored for you can use this situation. And then you end up with an answer. Remember, an integral finds the area under a curve. And of course, in this case, it's an indefinite integral. So you're going to come up with a plus c at the end. So somebody has to figure out the plus c. And it solves nothing. It's just a matter of a puzzle. It's like a Sudoku puzzle or a crossword puzzle that you're handling here. So I deal with this in programming it, and so I try to help you all I can, and with your tests or whatever you're going to use this for homework or whatever. Let's do it. Here's the integral here that we're going to find. I stands for integral. This has already been factored in the problem that I got off the YouTube, off the internet. I like to do these problems. When I try to search things, I search for something that's not very available, and then finally I find it, then I make sure my programs work with it. And of course it does. So let's do it. Index 8 to get to my menu. As I've said before, some people have said, hey, I put index 8 into here and nothing happens. Well, you got to go buy my programs. You got to go to my site and everystepcalculus.com and buy my programs, and then I send them to you in the email, and you download them into your calculator, TI-89 calculator, and take it to class, pull it out of your bag, and pass all these tests if you want to, or pass your homework, or if you want to learn about this stuff, certainly will help there too, but I'm not into teaching calculus. I'm into solving problems and doing the actual puzzle and figuring it out, okay? Step by step. Index 8 to get to my menu after you download my programs, and we scroll down with the menu. Menu comes about 180 items in this program, in this menu here. You access that by this clover leaf here. I'm already at partial fractions, so that save time. So let's go up here to, there's practical solutions. There's another fun thing to challenge you. And we're going to enter the integral. I've already put this in here so that the simulator here doesn't screw up, so this to save time, and it'll load here now. So you have 3x plus 1 over the, here's when you expand this factored situation here, you get this here, x cubed minus 2x squared minus 4x plus 8. Generally they give you this stuff in tests and stuff, and then you're supposed to be able to factor this. Good luck there too, huh? So I always give you a chance to change the whatever you enter into my programs here, so in case you made a mistake. So then we factor it, and here we come up with the factor here, just what is happening here. And we're going to set the problem up. Now, the way this is set up is that the numerator here, you multiply it times the denominator, and then the right side of the equation, after we set up the partial fractions, we're multiplying both sides times this here to come up with the proper format for partial fractions. Here's the left side of the equation, 3x plus 1. We're multiplying it times this here, the denominator, and we're dividing it by the same thing, which is the expanded version of the factored term here. And now we're going to figure out the right side of the equation. And we're going to set up the partial fractions on the right side, and we're going to also multiply that side by this same factor denominator. And we do this to eliminate the denominators on the right side. So we set up the partials: a over x minus 1, b over x minus 1 squared, and c over x plus 2. Numerator is all multiplied by this here, okay? So then I show you how to do this. We eliminate the denominator of a. So when we take this denominator here and divide it into here, multiply it times that, we come up with what's left: x minus 2 and x plus 2, okay? B, do the same thing. Here's x minus 2 squared. We're going to multiply that times the numerator, and we come up with x minus x plus 2, okay? And C, we do the same thing. So these are the setups of the, without denominators. You put, you know, a plus b plus c, with these values in there. And then we figure out, which I do for you, we figure out how to isolate b, so we come up with a value of 2 to do that. Just write this stuff on your paper. You're going to get partial credit or full credit for it, of course, unless you want to study it like me. I've studied this partial. I've been on partial credit for about a month now, checking all my formulas and doing this and doing that with it. So I know how to do these problems, you know, because anybody could. You could too if you studied it like I have. So we're going to replace 2 into all the x's here. The calculator puts quotation marks around it. If you do this, you're going to put parentheses around each one of those 2's. And then we do the computation. So the left side is 7, and the right side is a 0b times 4, and then b times 4, and c times 4, okay? When you do that, b turns out to be 7/4, because we're taking b4 here and dividing it on the other side, okay? Now we take minus 2 to do the same thing. We enter that into the equation. Turns out c is minus 5/16. We let x equals 0 to find a. And we put 0 in for all the x's. We have to do a little bit more algebra and computation for the a factor, because we're going to substitute b and c that we found here. So we do that. Here's 7/4 for the b and minus 5/16 for the c, times 4 and times what's left here. And when we simplify that, we get 7/2 here, and then minus 5/2. Notice minus 5/16 times 4 is minus 5/4, okay? And then we do our algebra. Minus 4 times a plus 9/4. We're going to subtract 9/4 from the left side. Turns out to be minus 5/4. And we're going to divide, we're going to do the computation here, divide by 5, and we come up with 5/16 for a. So we have all our partials. Now we set up the integrals. 5/16. Notice constants always come out of the integral before you integrate. And so when we go back to the original a, b, c formulas, we plug them in here. We bring the 5/16 out, 7/4 out, minus 5/16 out, a, b, and c. And then we integrate, compute, and then we get the answer here. I equals 5 times log of absolute x minus 2 over 16, etc., etc. Pretty neat, huh? EveryStepCalculus.com. Go to my site. My physics programs are even better than the calculus programs. I don't know. They take word problems and you solve a million of those problems. That's pretty neat too. Plus, you get my help too. If you email me your tests or quizzes, I'll show you exactly what's happening. If If there's a problem that we don't see in there, I'll program it quickly for you or set it up for you. You can call me or I can email me, and I'll help you all I can to pass calculus and physics. So keep that in mind, okay? Quite a deal for what you pay for these programs. And then, of course, you have it in your calculator forever. Throw away your calculus book because you don't need anything but this one here. And believe me, they're going to ram calculus down your throat for the rest of your life. You know, for your, and of course, you're going to have calculus for business, and later on, or maybe your partner or wife wants to upgrade her job, and so they have to get into calculus, or grandkids, whatever. So keep this in mind, okay? Good luck in your classes. I'm all for you. Okay? Bye-bye.